Question number 1. An object starts from rest and moves with a constant acceleration. Which of the following graphs best represent the variation of its kinetic energy with distance traveled? We can get an equation. If there is a constant acceleration, we can use v squared equals u squared plus 2a to find the final velocity. It is starting from rest, therefore initial velocity is 0. V squared equals to constant acceleration, we can consider it as a, and distance is given as d. This is the v squared term. Now we know that kinetic energy is half mv squared. Half m, we can substitute v squared to ad. Then we can cancel out 2 and 2. Kinetic energy equals mad. For the object, m and a constant, therefore we can consider that kinetic energy directly proportional to displacement, distance. Then graph should be in the form y equals mx. Then answer is 3 for the question number 1. Question number 2. If two objects collide in the absence of external forces, which of the following statement is always true? First statement, the momentum of each object remains unchanged. Now we can't get it. The kinetic energy of the object remains unchanged. The total momentum of the object remains unchanged. The total moment of objects remains unchanged. Direction of motion of each object remains unchanged. We know that when considering a collision, there is no an external unbalanced force. If there is no an external unbalanced force, we can get total linear momentum of the system should be conserved. Then we can get fourth answer is correct for the question number 2. The total momentum of objects remains unchanged. Question number 3. An electric motor pulls a 100 kilogram mass to a height 20 meters in 2 seconds. The minimum power needed for this. Power is the rate of energy used. Power is work done divided by time. Now, in the question, work done is given as the potential energy. We know that potential energy is mgh divided by time. Mass of the object 100 kilograms, gravitational acceleration 10, height is 20 meters. We have to divide by time taken to move the object 2 seconds. We can cancel out 2 and 20. Then 10,000 watt. Unit of power is watt. 10,000 watt. We can get it as 10 kilowatt. Then answer is 5 for the question number 3. Then question number 4. Two small objects of mass capital M and capital M and 2m are released from rest at height 2h and h respectively above the ground level. Which of the following is same for the both masses just before hitting the ground? Neglect air resistance. They have given speed, kinetic energy, time of travel, gravitational force acting on masses, momentum. There are different masses, m and 2m, and the masses are released from different heights. Then I will consider M mass and its height is simple h. I will consider speed of object when it hits the ground, final velocity. We know that it is under the gravity, therefore acceleration is g. Acceleration is g. Then we can get final velocity by using an equation. We can use v squared equals u squared plus 2a. We have to find final velocity. Initial velocity is 0, 2 times acceleration g h. Then root 2gh is the final velocity. When considering second object, mass is 2m, height 2h. No, they have given that height for this object is 2h, height for this object is h. Then we have to substitute 2h for this object, then root 4gh. When considering second object, we can write final velocity 2g, I will substitute this part, 2g, height is h, then final velocity 2gh root. Therefore, we can consider that final object of first object is a different value of the final velocity of second object, 4gh root, 2gh root. Then first statement is incorrect, the speed is not equal. Now I will consider kinetic energy. When finding kinetic energy, we have to consider that the final velocity of the first object is this one, final velocity of second object is this one. Then we can write equation for the kinetic energy is half mv squared, half mass m, v squared is the square of this term, we can remove square root. Then for the second object, half mass is 2m into kinetic final velocity is square of final velocity is 2gh. We have to remove this square root. Now, when considering these two terms, we can get that kinetic energy of first object 2mgh, kinetic energy of second object 2mgh. That is the same kinetic energy. Therefore, kinetic energy is equal is constant for the both objects. Then 2 for the answer. 2 is the answer for the question number 4. Question number 5. The particle falls freely from height capital H above the ground. Which of the following graphs represent the variation of total energy with height? We know that the total energy of the system should be conserved according to conservation of energy. When decreasing kinetic potential energy, kinetic energy should be increased. Therefore, total energy of the total mechanical energy of the system is conserved. Therefore, total energy is not changing with height. Answer is 4 for the question number 5. Total energy is a constant. Then question number 6. Two particles A and B have equal kinetic energies, but the velocity of particle B is 4 times that of A. The ratio momentum of A divided by momentum of B. You have to find the ratio between momentum. They have given that there are two particles A and B. velocity of particle B is 4 times the that of A. Then if the velocity of A is V, velocity of B is 4V. And there is the same kinetic energy. Then we can write half mass of A V squared. Half ma V squared is kinetic energy of A. Should be equal to kinetic energy of B. Half mb, velocity is 4V. 4V squared. Then we can cancel out half ma. We can cancel out V term, V squared term. ma equals 4 squared 16, 16 times mb. Now we have to find the momentum of ratio between momentum of A and momentum of B. We can write momentum of A, mass of A ma, velocity V. We have to divide by mass of B mb, velocity 4V. Then we can substitute ma as 16B. Then 16 mb V divided by mb 4V. Now we can cancel out V and V, mb and mb. 16 divided by 4 is 4. Then ratio is 4. Answer is 3 for the question number 6. Question number 7. Two particles A and B have equal momenta, but the velocity of particle B is 4 times of A. The ratio of kinetic energy of A and kinetic energy of B. We have to find the ratio of kinetic energy. Now they have given that they have same momentum. Then I will consider there are two objects A and B, two particles. Velocity of particle B is 4 times A. If the velocity of A is V, velocity of B is 4V. Now there is the same momentum. Then we can write mv product is the momentum. ma into V should be equals to mb into 4V. Now there is a relationship between mass of A and mass of B. We have to get the ratio between kinetic energy. We can write kinetic energy of A half ma V squared. We have to divide by half mb, velocity 4V, 4V squared, 16V squared. Now we can cancel out V squared term and half. And we can substitute as ma as 4mb. Then 4mb divided by mb into 16. We can cancel out mb and mb. 4 divided by 4, 1. 16 divided by 4, 4. 1 over 4 is the answer. Then we can get first answer is correct answer for the question number 7. Then question number 8. A cricket ball is hit for a 6. It leaves the bat at an upward angle of 45 degrees to the horizontal with kinetic energy K. Kinetic energy of the ball at the top of the flight is, we have to neglect the air resistance. Now I will consider the motion of ball. It is like this. Initial angle is 45 degrees horizontal, projected angle. If the velocity is u for the initial situation, we can write kinetic energy for the first situation. I will consider it as Ke1 half mu squared. It is the first equation. No, this kinetic energy is given as K. K equals half mu squared. first equation. Then I will consider the motion of the object at this point, top of the motion, top of the path. When considering this path, there is only one velocity component. It is horizontal component of this path. We know that there is no an acceleration for the whole motion in horizontal direction. Therefore, velocity component at this point, initial situation, u cos 45, it is constant for whole motion, then we can get velocity at the highest point is u cos 45. Then we can write kinetic energy at top of the path. I will consider it as k dash, half m square of velocity u cos 45 square, half m u square. We know that cos 45 is 1 over root 2. Now we have to substitute with square of this term. Square of 1 over root 2 is half. 1 square 1, root 2 square 2. Then it is the second equation. Now we can divide second equation and first equation. K dash divided by k equals to, when dividing second equation and first equation, we can cancel out half m term u squared. Now half divided by 1 is the remaining part of first equation. Then we can get k dash equals, we can bring k to the right hand side, k divided by 2. Then answer is 3 for the question number 8. Question number 9. Consider the following statement. A. If the kinetic energy of particle is constant with time, its momentum should be also constant with time. No, we can't get it. If kinetic energy is constant, momentum should be constant is a wrong statement. Because of, we know that kinetic energy is half mv squared. But there will be a different momentum. According to the question number 6, we have discussed there is a constant kinetic energy for both particles, but momentum is different. We have obtained there is a different momentum for object A and B. Then A is incorrect. Statement B. If the momentum of particle is constant with time, kinetic energy should also constant with time. We can get the relationship. If the kinetic energy is constant, momentum is constant, it means m and v constant. Mass and velocity is not changing. mv product is not changing. Therefore, half mv squared is the kinetic energy. It also should be a constant value. B is correct. C. If the momentum of particle varies linearly with time, its kinetic energy should also vary linearly with time. No, it is false. Statement C is false because of when considering linear variation, it means velocity is directly proportional to time. When velocity is directly proportional to time, momentum of particle is linear, but kinetic energy is half mv squared. It is depending with v square term. Therefore, if v is changing linearly, v squared should be changing like this. If v is changing with time like this graph, It means a linear graph, the square of V is changing with time like this. Therefore, we can't get a linear variation of kinetic energy. Then only B is correct. 2 is the answer for question number 9. Then 10. Total electric power generation capacity of Sri Lanka is approximately 2.1 gigawatt. If this power is to be generated by converting mass into energy, how much mass per second should be converted into energy? Velocity of light is given 3 into the 10 to the power 8. The electric power generation capacity of Sri Lanka is given as 2.1 gigawatt. What means energy per second? We know that when converting mass to energy, we have to use E equals mc squared relationship. Now they have given energy per second, then I will divide both terms by T, energy per second. Now energy per second is 2.1 gigawatt. Giga value is 10 to the power 9. 2.1 gigawatt, it is power. Power means energy divided by time. Then we have to find the mass loss per second. We have to find m over t value, mass loss per second, c squared. C is velocity of light. It is given as 3 into 10 to the power 9. Sorry, 3 into 10 to the power 8. We have to get square. Then we can simplify it. We have to find m over t value. 2.1 into 10 to the power 9 divided by 2 squared 9 into 10 to the power 8 squared 10 to the power 16. Now we can cancel out 10 to the power terms. 10 to the power 7 remaining. Then we can simplify it. We can cancel out by 3. 0.7 divided by 3. 0 divided by 3, 0. 0.7 divided by 3, 2. 1 remaining. 10 divided by 2, 3. 3. 3. Into 10 to the power minus 7. It is the mass loss per second. Now it is in kilograms. We can convert it to grams by multiplying 10 to the power 3. This value is in kilograms. We can convert this value to grams. We have to multiply by 10 to the power 3. Then 0.233 into 10 to the power minus 4 grams. Now we can convert it to milligrams. We have to multiply again by 10 to the power 3. 0.233 multiplied by 10 to the power minus 1. 0.0233 milligrams. Then answer is 1 for the question number 10. They have given for 3 decimal places. Therefore, they have given as 0.023 milligrams.